Okay, today we are going to look at the unit circle, which is in section 4.2 of your textbook. And the unit circle is something that we're going to be using a lot. And what a unit circle is a circle that has a radius of 1. And because it has a radius of 1, that tells us that the relationship between x squared and y squared, and then what we previously have called r squared when we talked about Sir Cox Retics with regards to the relationship between x, y, and r. Well, now that r value is a 1. And so in this right triangle, we have a y and we have an x, and therefore x squared plus y squared is 1 squared, and 1 squared is 1. So no matter what point we pick on the unit circle that has coordinates x and y, we know that when we square them and add them together, we should get 1. So an example question would be something like this. Is this point a point on the unit circle? And we can just simply check that by squaring each and checking, does that equal 1? If it does, then yes, it's on the unit circle. If it doesn't, then no, it's not. Now that's not all we're going to do with the unit circle. We're also going to look at how it relates to radian measure. And I don't know if you looked at the definition of a radian, but a radian is in fact an arc of the circle that is 1 unit long. What we're going to look at here is the relationship between the special triangles that we looked at in previous math classes and the relationship of those angles to the unit circles. So for instance, we're going to start with 45 degrees. Now if we look at our axes, which go east-west, so to speak, up, down, and left-right, x and y axis, and we talk about a line cutting it in the middle, we know that that's going to be 45 degrees because half of 90 is 45 degrees. But in terms of radians, what is that value? And we can convert that angle to radians by doing what we've done previously, but we also might want to look at, well, if we talk about this point, what would the coordinates be? We know that the radius there is 1. What would the value be of our x and our y value? Well, because we know that this is 45 degrees, we can use that as a reference, the triangle. And so for 45 degrees, the sine value of that is opposite over hypotenuse, which is 1 over root 2. And that will correspond to our x coordinate of root 2 over 2 here and root 2 over 2 there. Now you might ask why that's the case. And if we look over at the triangle to the left here, if I wanted to make this root 2 into a 1, I would need to divide it by root 2. So now that equals 1, which is the same as our 1 over here. Now, whatever we do to 1, we have to do the rest, so we'd have to also divide this by root 2, and those are each root 2 over 2. So a couple ways you can look at it. The triangle way makes sense to me as well, that therefore if this is 1, the only way we're going to get that being the case on the unit circle is if each of these x and y values are root 2 over 2. So what that tells us then, if I just clear a bunch of this ink off here, just give me a second, is that each of these arc lengths are the same. And so the question is, how is that going to change when I jump over to the point on the left-hand side? Same value, just your x value is negative. And if we go down to here, now they're both going to be negative. Yes, negative y, negative x. And you can probably predict what would happen in quadrant number 4. Similarly, we can apply the same principle to our 30, 60, 90 triangle that we've looked at before. Now this diagram is a little bit complicated. We're going to ignore these lines right here because those are the ones we just did. Those are our 45s. And we're going to look at what if we have a 30-degree angle right here. So this is my 30 degrees here, and if you look at the picture up there, we can kind of compare that. Well, this is normally 2, so I'm going to have to divide that by 2 to get 1, which makes that root 3 over 2, which makes that 1/2. So I'm going over root 3 over 2 and up 1/2. So that's root 3 over 2 and up 1/2. Now if it was 60, going to be the opposite. We're going to go a half and then root 3 over 2. So that point is now the opposite of that. So we have this, which would be go with that guy, which would go with that guy, which would go with that guy, and they're all going to be the same coordinate, just with different signs depending on where your x and y values are positive and negative, and same thing right here. Not too hard. So you're going to look at a bunch of other different type of questions, or we will look at a bunch of different types of questions. We're going to talk about where the coordinates are going to be positive or negative, and if you're interested in the answers for these without me talking to you about it, I thought I had the answers here somewhere. Excuse me a second. They're not there now. For this one here, you can pause it if you want and take a look at the answers. There they are, and maybe figure that out. If not, we'll go over it in class. Same thing here. If you want to pause the video and check out why these are the answers. Again, I'm really curious in questions C and D how you would go about getting the answers, because I would do it one way. I'm wondering how you would go about doing it. Otherwise, that's it. I should probably stop. Could get a lot more in, but we'll do that together. See ya later.